Good morning, students. In this video, let us find the equivalent resistance of a ladder network. The network consists of here the resistors connection as shown in this figure. So we need to find the equivalent resistance across the terminals AB. Here if you observe, this network consists of different number of cells. Here n, if you consider the number of cells, n value should be too large, almost infinity, such that the equivalent resistance across the terminals AB for n number of cells is equal to the equivalent resistance across the terminals AB for n minus 1 number of cells. Like that, this can be assumed if the number of cells is too large. Let us find how to calculate the resistance RAB. RAB, I am considering here X and Y terminals for n minus 1 number of cells, the equivalent resistance RXY. For n number of cells, it is RAB. So RAB is equal to RXY provided the number of cells is too large. I am considering this assumption. With that assumption, I am rewriting this circuit like this. I am replacing the resistor RXY in this circuit. So here I am writing RXY. This is 2R and R given in the figure. Here it is RAB. Now we need to find RAB. This is again, we can rewrite as these two are in series, so that this resistance is 2R plus RXY and this is R. This is RAB we need to find. Now these two are parallel combination of resistors. So for which the equivalent resistance is product of these two divided by sum of these two. So R into 2R plus RXY divided by sum of these two R plus 2R plus RXY. For the simplification purpose, I am assuming these two as X. Let us assume small x for RAB and RXY. Then we can write that equation as small x is equal to R into 2R plus X divided by this is 3R plus X. So we need to find the value of X now. Let us simplify this one. This is X into 3R plus X square is equal to, this is 2R square plus X into R. So further we can simplify as X square and X is 3R here, X R here. Let us take this side so that it is X into 2R. Next 2R square, let us take this side, minus 2R square is equal to 0. This is regular algebraic equation. We can compare with this standard equation ax square plus bx plus c is equal to 0, for which the solution we know that x is equal to minus b plus or minus square root of b square minus 4ac by 2. So we need to find the x value here from this equation. Let us write this equation here. We got x square plus x2r plus minus 2r square is equal to 0. Here a value 1, b value plus 2r, c value minus 2r square. And this is the solution for this equation. So we need to find x is equal to minus b, that is minus 2r plus or minus square root of b square, that means 2r whole square, 4r square minus 4ac, 4 into 1 into c value minus 2r square divided by 2. We need to simplify this expression. Here it is 4r square. Here minus minus plus. We can take this minus minus plus 4 into 2, 8r square. Here it is 8r square. Here it is 4r square. 8 plus 4, 12r square. That means square root of 12r square is nothing but, we can write it as 2 root 3r, right? We can write square root of 12r square as 2 root 3r. I am writing that one. So that x value is minus 2r plus or minus 2 root 3r divided by 2. Here 2 cancels and plus or minus is there. Here resistance value we are going to calculate for x. Resistance value is generally positive. That's why here minus means it will come into negative value. So we no need to consider the case for negative. So only positive value we are considering. So that x value is minus r plus root 3 r, or r value if you take it common, root 3 minus 1. This is the required resistance value across the terminals RAB. Like this, we can calculate the equivalent resistance of a given ladder network. For example, this kind of network is asked in IIT 1987 paper like this. I'll show you. The question asked in 1987. The circuit is given like this. The circuit in IIT 1987 paper is like this. Infinite. This is, he has specified in the question, infinite ladder network. We need to find the equivalent resistance across these two terminals. The resistance values he has given is 1 ohm, 2 ohm, here 1 ohm, here 2 ohm, like this. We can compare this network. We can follow the same procedure to find the equivalent resistance across the terminals A and B. I am going to calculate RAB, for which again we can consider here X and Y terminals like this for n minus 1 number of cells. So this is equal to RXY. We can assume small x. We need to find small x value, and let us replace with RXY in this circuit. This is nothing but this is 1 ohm, this is 2 ohms, this is RXY. We need to find RAB. Fine. So this one is parallel combination of two resistors. So this circuit further we are simplifying with a single resistor. Here it is RAB, here 1 ohm. Here parallel combination is nothing but product of these two resistors divided by sum of these two resistors. Again these two are in series. We need to find RAB. These two are in series. Let us find that value. So RAB, we can write it as 1 plus this one, 2RXY divided by 2 plus RXY. Here RAB, RXY we can consider as small x. So this one I am writing as small x, this one I am writing as small x, this one also replacing with a small x. So the resultant equation, x is equal to 1 plus 2x divided by 2 plus x. Further, we can simplify this expression as x is equal to 2 plus x plus 2x divided by 2 plus x. That is 2x plus x square is equal to 2 plus 3x. Fine. And I am writing this one as x square. This 3x we can take this side. So that is minus 3x plus 2x. That means minus x finally. And to this side minus 2 equal to 0. So we can compare this equation with a standard equation. For the result, x is equal to minus b plus or minus square root of b square minus 4ac divided by 2. Here comparing with equation, we are getting a value 1 here and b value minus 1, c value minus 2. Substitute in that equation. X value is equal to minus b, that is plus 1, and negative values are not needed for resistance, and plus square root of b square. So minus 1 square is 1 minus 4ac. So 4 into a value 1, c value minus 2 divided by 2. So we can simplify this one. So minus minus, we can write it as plus. 4 into 2, 8. 8 plus 1, 9. Square root of 9, 3. 3 plus 1, 4. 4 by 2, that is 2 ohms. So across these two terminals, the final resistance is 2 ohms. Like that, we can calculate the equivalent resistance value for a given ladder network with two large number of cells in that. Thank you.